The William W. Hay Railroad Seminar Series is sponsored by the National University Rail Center here at the University of Illinois at Urbana-Champaign. On behalf of all of us, we thank the U.S. DOT for their ongoing support. It is greatly appreciated by those of us here on campus, as well as those participating via the internet. Let me welcome today's internet participants. We have representatives from, a long list, Trans Systems, Northern Indiana Commuter Transportation District, Railstar Engineering, Federal Railroad Administration, Jacobs Engineering, Mott McDonald, SCRAA, LTK Engineering, K&K, Michigan Tech University, TUV Rail Sciences, Patrick Engineering, Amtrak, RSE, Sistra, Illinois Department of Transportation, the University of Illinois Fire Service Institute, and one more from Sistra as well. We welcome all of you. Appreciate that you could join us today via the internet. And I'll remind all of you participating that way that if you'd like to receive PDHs for your participation, please send Emma an email with your information as described in the email announcement for this seminar. So rail and transit infrastructure asset management has substantial data challenges at several levels. And while GIS, Geographic Information Systems, has helped to address some of these challenges, it requires specialized training, sophisticated software, and expensive computers, and these sometimes limit its reach. A potential solution is a web-based approach that would make it easier to share, show, host, and find big infrastructure data. Based on that principle, User Georeferenced Infrastructure Data Depository, or uGRIDD, was developed and can be used to more effectively manage rail and transit systems data. uGRIDD is presently being used by rail transit systems in Chicago, Philadelphia, and Washington, D.C., as well as other infrastructure organizations and projects. This presentation will provide an introduction to this technology and its application in a rail transit asset management. Our speaker today is Mr. Zhang Chen. He is a civil engineer, a land surveyor, and an entrepreneur. He completed his BS degree and MS degrees in civil engineering at the Illinois Institute of Technology in 1989 and 1991. In 1994, he founded the Dynasty Group, a Chicago-based consulting engineering and land surveying firm that specializes in design engineering, construction engineering, surveying, NDT, and GIS/BIM services. Under Mr. Chen's leadership, Dynasty Group has grown from a one-man company to a multi-million-dollar corporation, and in 2004, they expanded services into China. In 2012, Mr. Chen and his associates founded uGRIDD Corporation, this web-based service that offers cloud-managed infrastructure data through geospatial technology, and is the subject of his presentation today. Please join me in welcoming our speaker today, Mr. Zhang Chen, who will present the William W. Hay Railroad Engineering Seminar entitled uGRIDD for Rail Transit Infrastructure Big Data Management.
I'll back up a little bit. And as introduced, I'm a civil engineer, land surveyor, entrepreneur, and 22 years ago, and started a company called the Dynasty Group. Mainly we're doing infrastructure, surveying, civil engineering, and in the transportation area. And over the years, and the last 2 decades, the surveying equipment has been changed so much, from the total station, you point and shoot, to something like a terrestrial laser scanning, mobile LiDAR, the last picture shows, and also with the non-destructive testing, you're talking about the GPR, ultrasonic. So the ability in our business capturing data is growing dramatically. And with all of this data, are we really using that? Traditionally, and in our profession, the data has been collected and used for one function and one effort, then is archived somewhere, is really getting reused. So And what we're trying to create here is a data management system, cloud-based, and to address some of those issues. And look at how much previously people have studied how much we actually spend at the workforce to look for our data. And I found some study and online, and it just goes into the point. And at the workplace, we actually search and gather information. We spend about almost 20% of our time. That's a lot of human time spent just looking for information. And another professor at Purdue University actually stated that designers spend about 60% of their time searching for the right information, which is rated as the most frustrating engineer's activity. And we use computers, and if we cannot reuse what we captured by computer or created by computer, including all of those latest serving equipment, then we'll just keep reinventing the wheel. So with that in mind, and how do we do this? We capture a lot of data. How can we reuse that? One is, I believe the best way to archive our data is at when it was created or captured. Because if we purely rely on human memory, and sooner or later we're going to lose a lot of things. On almost every utility project and every asset project we go back, we always try to rehire some of the retired engineers. Why? Because they have the knowledge. They have been on the site. Another thing is almost like at childhood, our moms tell us, put your toy back to where you picked it up. So we need to put things at where it's at in order to be able to find it. That's a very simple principle. And I'll come back to the point, everything is somewhere. And so the question is, how? And so with all of those in question, about 10 years ago within Dynasty Group, we started talking about how do we do this? And GIS could be a huge help, but also it's expensive being a small company. And it's not a route we can afford, or also there's some limitations about the GIS. So about 5 years with all of this online map, whether it's a Google Map, with APIs, we started really implementing things. And talking about some of the limitations of the current technology, most of the businesses have a file server, probably more than one, including FTP sites, Dropboxes. What is that? That is basically a folder type of structure system. It's good to capture that, to have that, as a way to store information, but in that kind of system, very, very little metadata gets stored in there. We typically use the file folder name as the project number or the funding number, however your hierarchy is, but that's about it. And once you get a file name into 20, 30 characters, it's difficult to look at, it's difficult to manage. And so that's kind of the structure we have. It's, the computer has created a wonderful system, but still, and it has limitations. And look at the GIS. GIS is wonderful. It has been around for probably 40, 50 years. A typical GIS process, from capturing the data, register to the map, and interpret the data, and come up into the digital format, somehow store that in the computer, process it, finally to show the result. Typically, that process requires at least 2 disciplines or 2 fields. One is the user department, such as engineering department, such as a surveyor, to capture or create the data. Then you need what we call the GIS professionals in another department, the GIS department, to interact, to process that, then to publish a map, probably similar to this with the different layers. Then most of the people can actually use that interactively. And there's a bottleneck of, depending on how big of a GIS department you have. Also, with the professionals on the GIS side. And first of all, you get the training, and they get a limited capacity. And secondly, the software. You need a fairly expensive software and installations to manage all of that. And since the data is actually extracted from the original form or shape, the raw data, usually it gets lost, or at least some percentage gets lost in this translation or transportation. And the lack of ability to share and preserve the raw data will be another limitation. Typically, you go into a GIS system. Yes, you have a system you can use, but engineers, surveyors, when we try to reuse data, we want to go back to its original form. We want to know which benchmark we used, under what conditions it collected, even who collected, so forth and so on, all of that good information to give us the peace of mind to use the information. Would it be wonderful to have a direct connection from the user department, the engineering department, to publish it? With that in mind, I'll give you a quick demo, which is one of the functions on the uGRIDD web platform we created. This is a very simple Excel table. And many of us create this type of tables in our workplace. And it has a kind of a legible format of latitude, longitude, and it has the northern, eastern elevation, and with some other information on there. And so in the process, and I'll just jump into a function on the uGRIDD website, which we call data to map. And I also have the same Excel file, actually in Excel. So I just drag. Copy and paste into the box. Then the next, I'm going to have define a vertical datum and a horizontal datum. Since I know the data, pretending I'm the creator of the data, this is actually for the Navajo Nation, and they actually have their own projection. Usually surveyors would know that information, or if you're an engineer, you would know you're on the Illinois East or Illinois West state plan coordinate system, which is more common in this area. Just for information purpose, we'll put an AVD88 in there. So click next. Then, since I have Excel, I'm going to define my columns. The latitude and longitude are really just for display purpose, so these are text. And the northern eastern elevation, if you notice, automatically match up. And the surface elevation, I'll treat that as text. Description as the text. The source of the data as text. And then we can link other web pages or databases as a URL. Once you have the process programmed, this is how simple it is. It's very difficult for any one of us to look at those northern eastern elevation to imagine where is this in space. And these are the dots. These are the superimposed on Google Map, which we use the API as the background. So further, click on this. Since we're going to publish a web page, we need the title for the web page. I'll just call that a test for now. And we ask to pick a discipline. And this is serving mapping GIS type of data. And I'll just give a few characters of whatever that may be. And then there are some other features. And sometimes the data need to have some kind of security control. You don't want everybody to look at any data. So we can put a code, what we call invitation code. We'll put on simply 1, 2, 3. And with that, and this is the preview before we officially publish that. There's already a live URL actually on the internet. So if I review this, and since I'm already signed in as a user on uGRIDD, I'll put in the invitation code I just put in, 1, 2, 3. This is a live URL on the internet. By finalized, I can share this to as many people as they need. And by looking at all of these markers, these are actually monuments, survey monuments. And it gave me the metadata from the table, the point number, the latitude, long, northern, eastern elevation, so forth and so on. If I click this link, it actually link. This probably happened to be, an NGS monument. And so it actually live linked to the NGS website for the data sheet. So with workflows like this, many types of data can be processed and published through the uGRIDD website. The data to map is very simple, handling most of the tables. Something more heavier, like the LiDAR data, like a photo, a video, so far and so on, it can be processed and published. So another concept of uGRIDD, and I mentioned this earlier, everything is somewhere. This is really one thing interesting about our infrastructure business. We really build 2 bridges at exactly same location. It's impossible. So, and the ability for us to manage our data, if we can put the data at where it should be at, then we can go to find it, we can query it, very similar to if you turn on your cell phone, find the nearest Starbucks. It's exactly the same concept. So the concept is, and the goal is connecting people and data. Like I said earlier, luckily, everything we do in the infrastructure business, we usually create some sort of referencing system. And in the old days, as a surveyor, we put 2 points on the ground, call that 10,000, 20,000, northing, easting, due east. Then we start shooting, we start surveying. And then eventually the design will be based on that. So the referencing grid can be simply XY coordinates, or more globally, latitude and longitude. In a building case, it's a column line. Everything is referenced to the column grid, in a facility or in the building. Or as a land surveyor practicing, in Illinois, and the PLSS system, section, township, range, that is basically a grid system. So look at in our profession, what we touched on. People for different purpose at a different time create a referencing system for their need. So the solution to the problem perhaps is if we are able to interconnect all of this referencing system and hopefully find a common denominator of that, maybe that can greatly help to solve at least a part of our problem. And the common denominator perhaps is what is called the WGS84, simply most people know as the latitude longitude in a global sense, and that can be the solution. So we call uGRIDD User Georeferenced Infrastructure Data Depository. We're dealing with our business, although this particular presentation is more geared towards the rail and the transit. Obviously, this is the concept and the platform applicable to pretty much across the board, from bridge, highway, to facilities, to utilities. And one thing very interesting, this is kind of based on my and my colleagues' collective experience. If we really look into our business, in the infrastructure business, there are always 2 elements of it. Most of us, especially in the consulting business, we do project. So we're a very project-oriented company. Within one project, we drill so deep in there. And once you look at it collectively, with the whole, either the highway network or the transit network, on the operation side, is very much an organizational-based operation. The unfortunate part, due to the development of the technology and the business, very small percentage of the project data actually get archived at the organizational level. Even though it's archived in there, it's very difficult to find it. Sometimes it's probably just simpler try to recollect it. Again, for the consulting business, great, but at large, look at the whole society standpoint, the inability to reuse the data, at least, is a huge waste. So what we create at uGRIDD is, through a process, what we call uShow, meaning show off your data, visualizing your data. And we publish it on maps, very similar to the demonstration I just gave. I have a bunch of benchmarks, survey control points. I can process that, put that on a map. Imagine each project, you can easily have 10 to 20 maps. Then collective all of those web URLs, and through another process we call uCAN. It's kind of both the English and the Chinese meaning in there, and for those of you who understand Chinese. And collectively put all of the URLs, you publish it to your project team. So within the project team, if it's rather a large project, it has been difficult for everybody to know what everybody is doing in terms of the data being captured and collected. And if at the project level we can practice this way, then the entire team member would be benefited pretty much from everybody's data. And we call this project data sharing. Since we're doing this on the computers, it's very easy for us to track every piece of the data published. No different than you take 2 pictures of your dinner, post on your Facebook. You can go back there, edit it, you can delete it, you can do whatever you want with it. So it's the exactly same concept. Therefore, there's a pipeline from the published data goes into cloud data management system. Of course, there are already a lot of existing data. We're not reinventing the world from beginning point. So whatever at the organization level, there are already existing databases, even manual records through scanning, through other way to digitize them. And there's a process we call uShare. They can share that into the cloud data management system. Now the question is, it's great to have this archive. How do we find it? Location-based query, as I mentioned earlier. No difference than how you find your Starbucks on your cell phone. So we create something we call uFind. You put the location. We don't search for data because we want to search for data. We search for data because we have a job, or study on mind. So you put the location on the map, you search the data around you. So each of this, I have some demonstration coming up. So basically, the uGRIDD is aimed to show, share, host, and find infrastructure data, make it easier for professionals like ourselves. First, I'm going to do a quick demo of a CTA portal we have created. My engineering side of the company, Dynasty Group, has been fortunate enough to have done a lot of work over the last 5 or 6 years for CTA. I'll pick a couple of projects, and most of these projects involved with some kind of laser scanning documentation. This is the Dan Run track renewal project, which is about 10.5 miles. We use a terrestrial laser scanner, completely document this, actually before and after. And so when we first captured the data, there are over 400 setups of that laser scanner device. Besides, to ship this data on a portable hard drive to our client, one thing within Dynasty is, gee, how do we make this easier to access? Because the data is so rich, and it will be beneficial almost every discipline, every phase of the project. And one thing come to mind is, as an engineer or as a surveyor, regardless I'm working on track or I'm working on drainage, is, okay, I need to know where do I want to do my work. I want to know where do I want to find my data. Typically, okay, we're working on Dan Run. How about the Dan Run 31st? That's my assignment, in that thing to work on. So we list the intersecting roadways in here. If I click on 31st Street, the map will automatically fly to that area to demonstrate the yellow triangles where the laser scanner device was set up. We can also do that by stationing, by passenger stations. I can go on and on. To each discipline, however they prefer to access their data, as long as they have a way to do it. Usually, those nomenclature is tied into some sort of geoposition, intersecting of street, of roadway, for instance. Then we're able to program that in there to give the user the easy access. So let's go back to the intersecting street. I'll re-click on 31st. Then I'll click on this icon. It tells me somewhere 2010 or 2011, we collect the data with some general information. Then, before we even decide if this data is useful for us, we want to look at it. So this offers a panoramic view from the surveyor's eyes at that stop, at that position. And further on, since it's a LiDAR data or point cloud data, every single dot has its XYZ coordinates registered to the project coordinate system. Of course, we use the Illinois East coordinate system. So if I pick somewhere on this pier, pick another point on the ground, it gives me a distance. As a matter of fact, that we're showing on the upper left corner there is the slope distance, the horizontal distance, the vertical or the elevation difference, vertical angle, horizontal angle. Every engineer, every surveyor perhaps would ever need to extract the information. Another need perhaps somebody will need is, okay, we see the location of this pier. How about we want to know the coordinates of that point? So I simply click there. It gave me the XYZ coordinates. Keep in mind, this data is collected by laser scanning through whatever the surveyor's registration process, so it's very accurate. And whether the geoposition of the icon is within half an inch or within 2 inches, it doesn't really matter. But once we get into here, this is no different than what my engineers would submit to the client. This is no different than what they would use to build their base map. And further on with that, assuming you have a task to collect some manhole structures or pier positions or face of the abutment, so far and so on, I can do feature extraction. So if I enter a code and it gives you the XYZ coordinates and the code, I can just go to the other side and then click on another point, extract, giving the same code. So now I have 2 points. I can just build my little personal extraction on and on from the data set. Then with one click, we can export this data into a comma delimited data. Obviously, we can easily write the API to speed the data to a downstream application. And from here, the data can be imported into CAD or GIS or whatever the use is. On some of the projects I have been involved, a design engineer would have binder after binder after binder on his or her desk. And for instance, one of the things that maybe we'll be looking into, which I'm going to give an example, is the solver borings. And you have a binder, perhaps in CAD or on paper drawing, you will find a particular destination or borehole number. Then you go to the binder for the purpose of looking for a boring log. So here, again, I'm working on the 31st. Okay, I see a couple of boreholes here. These are actually environmental borings. I click on this. It gives me the XYZ coordinates with another click. This is your boring log. Simply, we survey the position of the borehole. The geotechnical company, or in this case, the environmental company, produced the analysis of the boring log. We simply just tie that position with that page of the boring log. And then processes, by the way, this map was exactly processed by the data to map. I just demoed. Whether it's a boring log or survey controls, it doesn't really matter. As most of us have cell phones, capturing a photo or capturing a video is getting easier and easier. And for the real engineering practice or surveying practice, capturing that is the easier task. It's even fun to go out there to shoot it. But when you come back to the office, figure out where you took the photo, to which direction you took it, and having some comment of that, that's a very tedious work. Usually tens, hundreds of man-hours would be spent on those. So one of our tasks is doing a photo documentation. By working with the CTA, we said, how about if we put a video on the train? Actually, we put 2 videos on the train. Because when you travel, you only see one side of the infrastructure. We want the rear camera to look at the opposite side of that. Then once we get a couple of hours worth of video, we were wondering there, gee, how do we find where we want to find? 31st Street, where's the 31st Street at in this video? Sometimes you have to just do trial, do it by trial and error. So one thought that came to mind is, let's put a GPS on it. So we put the GPS on the train. By synchronize the time between the video and the time log, the position log over the time of the GPS data, we're able to link the video and the map position. So with such an interface, again, if I click on 31st Street, both the video and the position, we purposely made it a little bit south of that since we're traveling northbound so we can see the bridge. And now I just passed the 31st Street. If I drag this camera back, the video will come back. Now, as you can imagine, if I want to fast forward or rewind the video, the map position and the video will be going to that spot. One of the buttons you saw is a video to map. That's exactly what it does. It takes the customer's video, it takes the correlation between video time and the GPS position, and publish that. For a fairly low accuracy video to map, you can do that on your cell phone. There are many, many apps record your GPS position by time. At the same time, turn on your video camera, put that in your car, drive around for 20 minutes, then you can do a video to map. And for similar application at another stretch of the CTA is the subway. Subway is very difficult for most people to access. And usually, people would really get access, at the station level. So I just want to quickly show you. This is what the subway looks like. And using a terrestrial laser scanner, capture it, produce whatever the record drawings. At the same time, the point cloud data can be utilized over and over for the user to consume the data, to look at the time of the scanning what is out there. We have similar applications, for the Washington Metro subway, and they get about a 90 miles track. We did a pilot earlier this year. Eventually, the entire 90-some miles will be on uGRIDD, I would say, by the first quarter of next year. And what's kind of unique is once the consultant who did the scanning and said, we have a stationing system. So I demoed that. Oops. Oh, find somewhere else. So let me get into one of these panorama. Linear referencing system is very difficult. It's very easy for a human being to look at it because it's linear, it's one direction. But once you try to use a computer to handle it, it's not that easy. Yeah, because the human mind that can make a lot of decisions on the fly about what I'm looking at. And so we build an alignment system into the data set. So now when we click on this, I just want to do a demo real quick. Not only we can have the XYZ coordinates, but also we have to have the station offset. So everywhere along the alignment. And the next version of the uPanel, the viewer is our own proprietary viewer. We call that uPanel. Will actually be able to visualize the alignment in there. But for now, at least any dot the user clicked will be able to see XYZ coordinates as how typically the data is registered to a datum, but also station offset or milepost. Actually, we have done some fairly extensive research about the railroad milepost. In railroad, a mile is not a mile. For those of you who have some experience, you know exactly what I mean. And there's a history of that. And actually, my both parents are engineers. I had a serious discussion with them on how should I handle that. And basically, you interpret it, you prorate it between the two mileposts. So in the uGRIDD system, we can handle what I call the engineering alignment with the stationing, which coordinates and the stationing offset work nearly perfectly. I'm carefully using my words nearly, for the calculation. But in the milepost situation, then, if you have a 0.5 of a mile, it's really the mid position between two posts. And so we have that built in there. Another thing unique for the SEPTA system, we're working with Macer Consulting, who is a serving company and a serving engineering company in the East Coast. And what they choose to do is this is to support some renovation of the streetcar system in Philadelphia. And besides a LiDAR, mobile LiDAR truck, they also installed a panoramic camera on there. So the question and the challenge to us is, we love to see the panoramic camera, but can we make it line up with the point cloud data? With the equipment installed and tested to a certain accuracy standard, yes, we can. And there are a lot of very complex math in there. You know, in the surface, what you're looking at is very, very similar to Google Street View. And we even have the next scenery in there, and you can move to. But the ability of click, for instance, I'll do this on this lapel. Click on this lapel to get the XYZ coordinates. It takes a lot of math to sync between the photo pixels and the LiDAR pixels, then on the fly to do the calculation. But it's very powerful. You know, they love it because they literally look at a street view alike type of data set with the ability to have the measurement, the coordinates, the picking, and make it a lot easier and for the people to use the data. Coming back to at the organization level, we're looking for data. As I said earlier, everything is somewhere. If we're able to sort of register our data set to where it belongs to, you know, and globally, and what we're able to do is this. Let's say I have a project at the centroid point of my zip code in downtown Chicago, 60606. And since I have a project, this will be my location of interest. I call that an LOI. As you can see, I have a layer turned on. You know, I have a lot more layers in the Chicago area than elsewhere in the nation. And using the layer, I'm looking at bridges. So if I click bridges, 177 bridges showed up on the map. And where did we get the data? National Bridge Inventory. They offer an Excel table with about 700,000 bridges. Those are all federal-funded bridges. And by putting that database in there and georeferencing them, we're able to query 177 bridges out of 700,000, like half a second or less. If I increase the search buffer to 10 miles, we're going to get about 1,054 bridges. So if I click on one of these bridges, it opens up in the state of Illinois, carrying Washington. We actually link to the local DOT website. Illinois and Georgia, surprisingly, are the only two websites offering the detailed inspection record online. Anybody, it's public information. Anybody can go on there, look at that. And we also list all of the attributes, you know, in the database, in the National Bridge Inventory database, and so you can look at that. And by turning the bridge layer off, as a surveyor, the first thing I did was NGS monuments, and certainly that's very similar. And I click on one of these markers, and then we can easily get into the NGS data sheet. Another thing interesting, and which took us a little time to figure out, was PDF drawings. For instance, in Chicago, we have something called the 80-acre sheet, which is the street atlas or city wall maps. And those are historical PDF drawings. How do you handle that? But keep in mind that we have a grid system, PLSS. Each 80-acre sheet, the reason there are 80 acres is they're half of a quarter section. Same with city wall maps. So since I know that, since I know where is each section is at, can I calculate the centroid point of a half of a quarter section? Yes, I can. So by calculating that, if I turn off the NGS monuments and click on the layer we call 80-acre sheet. So these are the 80-acre sheets. And usually as a surveyor, my job will be only about a half a mile within the neighborhood. So there are 8 sheets shows up. By clicking on this, we're actually live pulling the 80-acre sheet from the CityGS portal. This is much easier than knowing where you're looking for, 31st and then run, dive into your map. Instead, you know where your job is at. You put the location of interest down there, then you search for the information. And with a similar approach, a lot of utility atlas, most of them are actually filed by a quarter section or half of a quarter section, can be searched exactly the same way. And I can go on, and we have a layer for the railroad crossings and things like that. And nationwide, here's the railroad crossings, and we offer that. You can get into, the accident data report of that. Another function is the concept of a location of interest. It doesn't have to be a point. It can be a line, can be a shape. Because if I'm working on a linear asset, a stretch of street, if I digitize, a very small portion of a street and reduce, I'll go this way, reduce my search to like 1,000 feet, and then go for instance, the bridges, then the bridges along that right-of-way will pop up. So there are a number of ways to program this in and to develop the applications. And with that, and if we're able to somehow managing at the cloud, data management system for all of the data we captured, whether it's a LiDAR, whether it's a photo, aerial photo, or BIM, or CAD drawings, and so on and so on. And the future possibility is most of the operation control systems these days are based on a database with an alphanumeric type of data. If you walk into a railroad control room, you probably see the track chart on the wall or on a big monitor, things like that. And by tying in the key positions, such as the switch positions, the signal position of that, then that will enable the operator easily access the infrastructure data, and vice versa. And the folks who work on the bridges, work on the switches, and doing the maintenance can actually interact, with the operation control software. So we're exploring some of those options. Unfortunately, I'm not able to show an example. With that, thank you for listening, and any questions? Thank you.
We definitely have time for questions, so. I guess I have one. So have you, I know you've used this with some transit properties and SEPTA, kind of commuter rail. Have you worked on, what are some of the specific sorts of problems that they're using this for to help them do a better job?
Well, I think one is, for instance, the CTA engineering department is very interested in using this and to just capture their data and archive their data so that they always have a record of at one time what's being collected. Also, the LiDAR data with the richness of the LiDAR data, and it eventually goes into many, many directions from supporting for their next project to supporting other disciplines. So that's one of the interests. I think WMATA and the SEPTA have a similar vision to that, and some class ones, and I'm not able to show that. Maybe they want to interface this, with their PTC or with their asset management, because almost every conference I go to listening to the presentation about the PTC now is at the time, okay, we get all of this data. How can this data benefit our operation, help us, save time and save money? And so by having the ability to visualize, to access the data, and hopefully that will bring up some possibilities.
If I could ask another question. How long does it typically take for, so let's say use CTA as an example. Mm-hmm. How long does it take to sort of get the system up and running for a system of that size, let's say?
Very good question. For instance, using the Danran as an example, it's about 10.5 miles, and we laser scan that. And the process of capturing the data, register the data, is the usual serving engineering process. Once that is ready, to publish that data is a matter of a few hours for that kind of data set. We're talking about probably in the tens, if not in the hundreds of gigabytes.
Other questions? We have one from oh, go ahead.
Are there situations where you come across problems with intellectual property rights?
Not so much, at least not so much as of yet. The data, I think, on the public side, on some of the layers that we're showing, these are public available data. Basically, the data is collected on and there are certainly certain data, for instance, with the class 1s or with the oil and gas company, I couldn't show, which is their data. We have NDA in there, and the data always belong to the customer. uGRIDD is not in the data collection business. We're in the business of helping the customers to better access, basically the 4 words, show, share, host, and find, their data. So imagine the picture is theirs, the frame is ours, and so that sort of thing.
We have one question from one of our internet participants. Her question is, what are the main challenges in capturing and analyzing the data, which is a pretty broad question.
Yes. It really depends on what kind of data. And as of now, at the project level, the project has a certain goal, and either my engineering company, Dynasty, or another customer would collect the data for whatever their immediate goal. And then what the uGRIDD will come in to help is basically extend the life of that data, whether it's from a few months to a few years, and so that multidiscipline, multiple departments can be benefited from that. So the analysis side, the analytics side, as of now, is still being done at each customer level for whatever their needs are. Yes, sir.
How much problems do you have with public available data sets that are less than fully accurate, I guess, and then that would be brought in, and then, gee, this bridge is not where it says it is, or that kind of stuff?
Well, I actually created a bridge in Chicago. Actually, most of the bridges is not really at the central point of the bridges. So for uGRIDD concern, whatever the data we were given or we found is whatever the value of data. Actually, I didn't show this. Behind each layer you'll find we actually disclose where we get the data, when we updated all of those metadata information. And on the project side, again, the burden is on each surveyor and engineering firm to collect and create their data to the accuracy. And again, uGRIDD is just the platform and the messenger. And so we actually have a very serious discussion in our development process. Do we want to get into the business of other people's data accuracy? No, we don't. And it's almost like you read the article. Whether your article is good or bad, somebody will publish it or not publish it. It's between you and the publisher, not Microsoft Word.
Question. The demos you were just doing were live online, right?
Correct.
So here at the university, we generally have pretty good bandwidth. But I can imagine some field locations, there could be more constraints on that. Is there some way your system can account for, give you sort of partial functionality at with poor internet connections, or has that not usually been a problem?
When we develop the viewer, there are 2 sides of this. One is the viewing side. We certainly have that into consideration. And we have full stack software engineers looking into that. And during our process, if we load some data in the background, what do we load first, what do we load second? And basically, the goal is to optimize the viewing experience for the users with the consideration of the internet speed, even version of browsers, things like that. The other side of the equation is when they try to process and upload the data, and if they have a very, very narrow bandwidth, yeah, that can be difficult. And actually, I had a serious discussion with a potential customer in Africa, and they said, well, our bandwidth is very narrow, so how do we use this? And yeah, we have no choice to do it by trial and error to see what works or won't.
Asking all the questions. I'm fascinated by this. Another use that occurs to me would be in an emergency response situation.
Yes.
Management may need to very quickly gather information on a variety of parameters. Are you familiar with any of your clients using it in that situation yet?
Not to my knowledge at the moment, but certainly a lot of people we're talking to and has thought about that. And if we can get this linked to EMS and what they can use with it.
Yeah, I mean, again, one of my areas of specialization is hazardous materials transportation safety. In the event of a hazmat spill,
right,
you may very quickly want to know information
That's right.
about susceptibilities or other things in the vicinity of the incident. And,
right.
I could see this being useful for
Right.
that.
We have a customer who provide the business to others and have done studies with for instance, the transportability of some material or some goods, whether it's a very larger, objects, and then publishing the result on that. Where people trying to, with the LiDAR data and putting twin vibration envelopes on it, and to publish those kind of a study in there. So there are all sort of applications, we may not understand, we may not get involved. Simply, they're just using the tool to share the result or to share the thoughts, with their colleagues. Oh, thank you very much. Appreciate it.